At low voltages smaller than cut-in voltage, value of recombination factor becomes significant, reducing current gain parameters. But problem also arises when the biasing voltage becomes significant. This leads to high level injection where the excess carrier concentration becomes comparable or greater than majority carrier concentration. In such cases, because of more number of excess minority charge carriers of base move towards emitter, emitter injection efficiency reduces, which further reduces the current gain parameters. That is the reason why high level injection in BJT are not preferred. In practical BJT, the applied voltage on emitter creates a potential drop literally on the emitter. More current from base goes to emitter from the edges and very less to no current goes through the center. This creates localized heating effects as well as localized high injection effects. Emitter band gap narrowing. We have already studied band gap narrowing effect in the first unit where when we increase the doping to very high values, then the donor energy level splits into a band of energy and combines to the conduction band such that the effective band gap energy reduces. This leads to increase in intrinsic carrier concentration. It should be clear by now that heavily doped emitter is favorable for BJT, but it also has limitations. If we keep increasing the emitter doping above its acceptable point, then the current gain parameters will begin to decrease. Consider p-type emitter with minority carrier concentration equal to square of intrinsic carrier concentration divided by doping concentration of emitter. Considering band gap narrowing effect, minority carrier free electron concentration will be equal to square of intrinsic carrier concentration divided by emitter doping concentration into exponential of change in band gap energy divided by Boltzmann constant into temperature. So, if we increase the doping concentration further, the minority carrier concentration will actually increase because of exponential term and will increase minority carrier current, which will lead to decrease in emitter injection efficiency, which will further lead to reduction in current gain parameters.